All right, so this is day 2, our next section for unit or section 2.1 in our reasoning and proof unit. This is about what's called deductive reasoning. So we're going to determine here what the difference is between these two. Yesterday we learned about inductive reasoning and making conjectures. So let's compare the two, okay? So deductive reasoning, go ahead and get this definition in your notes. It's a process that uses facts and definitions, okay? Hard facts, right? Definitions and accepted properties and logic to form an argument or form a conclusion, okay? So the biggest takeaway here is that for deductive reasonings, we really need facts, we need examples, okay? Compare this or contrast this with what we learned the other day, okay, with inductive reasoning. Inductive reasoning is making conjectures, okay, or coming up with something. So making conjectures based on patterns, okay, so there's a difference there. Patterns are just things that you kind of have uncovered based on your experiences, right? Facts are true. Facts are known to be true. They're accepted. They're definitions that we've come up with, and so they're more of a hard truth, right? Patterns are more of something you've noticed, or you're making predictions about something based on your experiences. Okay, so there's a subtle difference there, and we're going to see here in some examples the differences between the two. Okay. So we need to figure out, does each argument use inductive or deductive reasoning? Okay, so we're really, my advice would be to look for some facts or look for some patterns that kind of are in these statements. Okay, so let's figure out if we can do these together here. Okay, Heidi likes all vegetables, and peas are vegetables, so therefore Heidi likes peas. Okay, and so there's facts here, right? Heidi likes vegetables. That is a known fact, right? She said that she likes vegetables. Okay, I personally do like vegetables, most vegetables too, right? Broccoli is probably my favorite, but she likes all vegetables. Okay, and so therefore she likes peas. This would be an example of deductive reasoning because we're using facts. Okay, so this would be a fact right here. Okay, let's try another one. Let's compare that with another one here. Plants can grow to be healthy when given sunlight and water. Mark's plant receives sunlight and water each day, so Mark's plant will grow to be healthy. Okay, notice here it says plants can grow to be healthy when they're given sunlight and water. Okay, so we've noticed over the course of our life, right? If I water a plant and I give it sunlight, more than likely it turns out to be healthy, right? We've noticed some type of pattern. Okay, this would be an example of a pattern. Okay, it's a very subtle difference, right? But it's not a guarantee that if you um, give a plant sunlight and water that it's going to be healthy. Okay, we're assuming or we're predicting based on a pattern that Mark's plant will grow to be healthy. So this is inductive reasoning. Okay, let's try some more. So the rain stopped and the sun came out. Next, a rainbow will appear. Okay, so usually think about when you've seen a rainstorm and then the sun starts coming out, right? Sometimes we see rainbows. We anticipate them. We predict them that they're coming, right? This is another example of a pattern here. Okay, we've noticed throughout our life, right, that when the rain kind of starts slowing down and the sun starts coming out, we look for a rainbow, right? So this is based on a pattern and therefore is inductive reasoning. Okay, let's try another one. So it says Jose put $25 into savings each week for 10 weeks. Therefore, Jose has put $250 into his savings during this period. So that's um, all facts, right? He put $25 into his savings each week for 10 weeks, and therefore he has $250. That is deductive reasoning. Okay. Here's E. It says quadrilateral ABCD is a rectangle. Okay, we're going to learn about this later in the year, about four-sided shapes and the different kinds that there are. All rectangles are parallelograms. Therefore, or so, ABC is a parallelogram. That follows a line of facts, right? First we say that it's a rectangle, then we say rectangles are parallelograms. Therefore, the shape we started with has to be a parallelogram. Okay, so since we have facts here, this is deductive reasoning. Okay, the more practice we get with these, the better or more accustomed you'll be to kind of recognizing which case is which. So I want to give you a lot of examples here in your notes. Okay, it says if you pass Algebra 1 with a C minus, then you move on to geometry. Joe failed Algebra 1, so he's not in geometry. Those are true facts, right? That's not a pattern. That's the rules of the high school, right? That's the rules that we follow. So it's facts, and therefore is deductive reasoning. Okay. Flip your notes over, and when you're ready, go ahead and follow along with this example here. So Ken has eaten a peanut butter sandwich every day this week for lunch. Tomorrow, Ken is going to eat a peanut butter sandwich for lunch. Okay. Now, I think it is a fact, right? It is a fact that he's eaten a sandwich every day this week for lunch. He's eaten a peanut butter sandwich every day this week. So that could be, you could consider that a fact, right? But we're making now a prediction based on what he's going to do, what he's done in the past. We're making a prediction about the future. Tomorrow, he's going to eat a peanut butter sandwich for lunch. Okay, so this right here is more like we're going on a pattern, right? We've seen a pattern of something happening. Every day he's eating a peanut butter sandwich. I'm predicting, or I'm guessing he's going to eat a peanut butter sandwich again tomorrow. Okay, so since this is based on a pattern, our reasoning in this case is inductive. Okay, and the last one here. All of Sarah's friends have cell phones. John has a cell phone, so therefore he's Sarah's friend. Okay, that's more of like an assumption, right? We're assuming that they're friends. Okay, however, we're trying to go on some type of pattern, right? Since all of her friends have phones, and John has a phone, well, he must be her friend. Well, that's not necessarily true. However, our reasoning here is still based on inductive reasoning because it's based on a pattern or an assumption. Okay. So those are a bunch of examples for you. Hopefully you're getting a little better feel for kind of discerning those two. Let's talk about making conclusions now based on some statements. Okay. So in example 2, what if anything can we conclude? Okay, so here we have a statement that says, if a figure is a rhombus, then it is a parallelogram. So what can we conclude based on this? Using different types of reasoning, right? So if it's a rhombus, then it's a parallelogram. Well, this shape, D-E-S-K, which happens to look like the word desk, right? But it's a shape, it's a figure, okay, that has these endpoints, D-E-S-K. So maybe draw that picture to help you. Okay. If a figure is a rhombus, then it's a parallelogram. Well, it says this is a rhombus. Therefore, we can conclude, okay, these little dots here mean therefore. Okay, therefore. We're going to use that in this class. Therefore, it is a parallelogram. Okay, that's what we can conclude about it. Okay, let's try another one here. Now, there's a couple statements here, if-then statements, right? So it says if x is equal to 12, then y has to be 10. But if z is equal to 4, then x is equal to 12. Okay, so they kind of seem like they're out of order a little bit, right? It seems like this second one kind of leads into this one, right? So if z is 4, then x is 12. If x is 12, y is 10. Okay, so here's our statement right here. Okay, z is 4. Z is equal to 4. So what can we conclude? Well, if z is 4, then we know x is 12. If x is 12, then y is 10. So we are allowed to conclude that y is equal to 10. Okay, we can also say that x is equal to 12 as well. That's another something you could conclude about that, okay? And both would be true. Okay, let's see if we can conclude anything about this. Whenever someone gets out of the car, a sound is made. And someone got out of the car, right? Notice I switched those around. We have to be careful about which one comes first, right? We're looking for a statement. This is kind of the statement right here on top that we're trying to make a conclusion about, right? So pretend that this might be down here. This is kind of like our question right here, right? So if someone gets out of a car, a sound is made. Well, someone got out of the car, so we can conclude that a sound is made. Okay. All right, let's do a couple more here to get practice with making conclusions based on statements and using different types of reasoning. Okay, so here's our statement we're trying to conclude on this one. If x is equal to 22, then y is equal to 4. Well, this statement says, well, y equals 4. So can we conclude anything? Now, this is a little tricky, but not necessarily, right? We don't know that just because y is equal to 4, that x has to be 22 or something else is occurring, right? We can't really make that conclusion. Okay, it's not necessarily true the other way around, right? We don't know that x has to be 22 if y is 4. X could be something completely different, even if y is 4. Okay. So I'll say not necessarily true the other way around. Okay, so we're not going to be able to conclude anything. We'll say nothing on this one. Okay. Our last example here for this section says, I go to bed if I finish my homework, and I fall asleep if I go to bed. So it says maybe this is our statement here, right? I finished my lessons tonight. Okay, or you could even say, let's make the word homework there. Okay, I think in your notes it says homework. Okay, I finished my homework last night. That's our statement, right? Let's try to piece these together. This is kind of like example B up there, right? Where they're seem like they're a little bit out of order, right? So let's read them a different way. I fall asleep if I go to bed, okay? And then, if you read the next one, I go to bed if I finish my homework. So this one says that I finished my homework last night, okay? Therefore, I fall asleep, right? We can kind of, didn't spell that right. There we go. I fall asleep, okay? Since I finished my homework, if I finish my homework, then I go to bed. If I go to bed, I fall asleep. Okay, so it says I finished my homework last night. So you can kind of follow backwards through this and see that then you can conclude that he fell asleep. Okay, that is it for this section. So give the homework a try and let me know what I can help with.